Hello there, I'm Laura. I'm a software engineer and I work on Android search.
Hi, I'm Simon. I'm an engineering manager here at Google and I work on the Chrome browser. We're broadcasting tonight live from Google London and we're very excited to be kicking off this live YouTube live session as part of the Get Ahead program. So today is all about interviewing at Google. We won't go into the whole process, but we'll focus on the actual time you spend in the interview itself. But I'd like to start by welcoming you all and thanking you for spending your evening with us.
Okay, so each technical interview at Google is 4 to 5 minutes long, and usually for internships you will get 2 of these over Hangouts.
But if you want a full-time role, then there'll be an additional 4 or 5 interviews that will take place actually on-site in the Google offices, and you'll be writing code either on a whiteboard or on a Chromebook. So many of you have already interviewed with us, but for those of you that haven't, I think today will be a good example for you to see what goes on in an actual interview. So I'm going to be asking Laura the kind of questions that you'll be asked at a Google interview.
Now, to be completely honest, this is not the first time that I've seen this interview, and this question in particular, so I'm going to be writing code a bit faster than you would normally expect in real interviews. I am going to get some things wrong, and we're going to look at those and see in how many ways I could improve. So we have Regan and Charlie moderating our chat functionality today. So please go ahead and do ask us questions. We have a Q&A section at the end, so we will try to get as many of those answered as possible. So having said that, I think we're ready. Should we get started?
Let's do it.
Right.
So nice to meet you.
Thank you.
I'm Simon.
I'm Laura.
Is this your first interview at Google?
It is. I'm very excited.
Well, that's good. So now then, we'll dive straight into code here. What I will do is I'll ask you a question and let's see how your thinking goes. So suppose I give you a list. 1, 2, 3, 3, 3, some 3s, 4, and a 5. And I ask you to write some code that finds the number 3 in that list and how many occurrences there are of that number.
Okay.
Well, there you go.
Right.
So now Laura's thinking about it, but she hasn't asked me any clarifying questions. She's just gone straight to code, which is not very good, really. Okay, so you've called your function solution.
Right.
That's a terrible name for a function, solution. It doesn't tell me anything. I have no idea what she's thinking. Is she even answering the right question? Maybe she's misunderstood. I don't know. So what's this? X, Y, C. What does C stand for?
For it's, I'm just going to count the number of 3s in the.
Right. She's not telling me what she's doing. She's just repeated back the question to me, really. And she's writing a for loop. So far, I know that she can do for loops, which is not that challenging. Right. She's just not saying anything. This is going really, really badly.
Okay, so I'm done.
Okay, so Laura has written a really trivial solution there that is not interesting to me at all. I've learned nothing about her skills and her knowledge, and I think it's not good enough. So I'm going to pause, Laura, and we're going to rewind and we'll try again. Right, so you've got a list of numbers and I want you to find the 3 in there and how many occurrences there are of it.
Okay, so you're saying this is going to be a function that needs to count a number from a list.
Yes, so I'll give you the 3 and you'll tell me 4. There are 4 number 3s in there.
Okay, all right, and it's this one is ordered. Can I assume that the list is going to be always sorted?
Yes, absolutely. That's a good observation.
Okay, and
so this is going good.
And is the 3 the only one that can appear, that is going to appear multiple times? I mean, this could be this, for example, 2, 2, 3.
Could be 2 2s. So this is going much better. She's asking questions. I'm learning about how she thinks about things. So this is much better this time.
Okay, and can I assume the 3 is always going to be on the number that I'm looking for is always going to be on the list?
If the list wasn't in, if the number wasn't in there, what would you expect the result to be?
well, this is returning the count, right? So if I suppose if you passed in, I don't know, 7 to this, I guess we could just return 0. There's 0 sevens
Absolutely.
on
So
on
let's
this
do
list.
that.
Okay.
Yep.
Okay. All right. So this is what a signature would look like, I suppose. It's going to return an integer
Yeah, that's great.
for the, and I'm going to call this count.
See, that's a
So we're
better
ca-
name. Before it was
we're
called
counting the
solution.
numbers.
Count is a much better name for the function.
Is it okay to return an integer? I mean, can I assume there's going to be few numbers? The number's going to be small enough that it's going to fit in an integer, right?
Yes, that's fantastic. That's a really good observation.
And it all's going to fit in memory. So this could be an array of integers.
They all fit in memory, yes.
And I'm calling NS for numbers.
Yep, that's great.
And I
So
suppose I pass a target and I call it T.
Yeah. So Laura's thinking about scale here. She's thinking about how many numbers they're going to be, and this is all really good. As a Google engineer, this is what we want. We want people to think about scale.
So is this the signature of the function that I'm going to implement?
Looks
Is that
fantastic.
Okay.
Yeah.
Okay. So the most trivial brute force solution that I can think of is simply scan the array. I know it fits a number, so I can do it, and
Yep.
I'm just going to scan it, count how many of these 3s are in the array, and return that number.
Okay. Now.
But this, no, I'm just saying this doesn't take advantage of the fact that the list is sorted.
That's true. Now, interestingly, Laura has just told me the brute force solution, which was much quicker than actually having to write the code. And by telling me that it's a trivial brute force solution, I've learned much more than her just writing the code as she did before. So this is fantastic.
So I suppose because the list is sorted, I could do a binary search on it.
Yes,
And
that
if
sounds good.
I'm looking for just one target, so I'm looking for a 3, I could do binary search and find a 3.
Yep.
And then the only thing that I have to do is count how many 3s appear to the left and to the right side of the 3 that I found with my binary search.
Yeah.
And I haven't had to, since the list is sorted, I don't have to scan through the whole thing. I can only stay within the 3s, like within my target. And then
Okay.
the moment I see something that isn't a 3, that isn't my target, I can stop.
So you're proposing
Right.
binary search to find a 3 and
Right.
then a linear scan from that point?
Right, to the left and to the right.
Right. So
But it's a much smaller scan because I don't have to go through the whole array.
right. You might have to go through the whole array. I mean, worst case, if they were all 3s, don't you have to go through the whole array then?
Well, yes, but on average, on an average array, I would expect this to still be logarithmic.
I don't know what an average array is.
Well, yeah, but if like amortized, if I do this several times on several arrays, I would expect for this to be
Right,
to
but
be a
but
logarithmic
worst case. Tell me about worst case here.
Yeah. Okay. So yes, worst case is going to, if I find it, is going to be a scan, but still, it is much better than scanning through the whole array from the beginning.
Right. So I feel like I'm having an argument with Laura here. I'm trying to give her a hint that actually there's a better solution, but she is refusing to take it. She's sticking to her guns, which is not really a good thing to do in an interview. If you're being heavily hinted, then either you're missing something, or worst case, you can just say to the interviewer, you're trying to hint at something, can you be more explicit, please? And don't be afraid to ask. Laura's just going down a rat hole here. So I think that Laura should try again.
Okay.
Right. So you've got a 3. You're talking about doing a binary search.
Yeah, and you were asking me about the worst case.
Yeah.
It's true that if I scan left and right, and the worst case would be something that has all of, suppose I'm looking for a 3, and the worst case is a big array that has all 3s on them.
Yeah.
My binary search would be super fast. I'm going to find a 3 immediately because it's going to be right in the middle. But then I have to scan left or right for the whole thing, and I don't
just
get
linear.
any less linear than I was before with the brute force approach.
Yep.
So are you saying that should I try and improve on this solution and make it
Yeah.
sublinear?
Yes, I think there's a logarithmic solution.
There is a logarithm.
Yeah.
Okay. All right. So something that what I'm thinking here is if I really literally go and inspect all of the numbers that match my target,
Yeah.
it's never going to get sublinear because there's always this worst case.
That's
So
true.
I'll have to get away. It's about finding a way that I can count without really like looking at them all.
Yeah.
So
Having any
well,
ideas?
I'm thinking if I somehow knew that because the array is sorted,
Yeah.
if I find the first occurrence of the 3 and the last occurrence of the 3, I can then just simply subtract the indices, and that will give me the exact count of 3s in the array.
That's a
And-
really good thought. Yeah.
And then, but finding the first occurrence and finding the last occurrence, that I can do logarithmically with a binary search, with a version of the binary search that doesn't look for just any target, but the first occurrence and the last occurrence exactly.
Excellent. That sounds really good. So Laura has stumbled upon, or she's figured out, a really good solution there. And I think hopefully it was my hinting that helped her a bit, but she's figured out a good way to proceed. So do you feel that you can write that code?
Yeah. Okay. So let's. So this should be quite simple. So here I have the. I'm going to find the first occurrence of my target and the last occurrence, and then do a simple subtraction.
Yep.
So I'm just going to delegate to a function to write later. I call this f for first, and let's suppose I have find first.
Nice.
That finds my first index.
So this is really good. Laura
And
is
then
writing
back
helper
and
functions here,
T.
and that may look a bit like cheating, but actually she's going to write the code later because I'm going to ask her to. And it shows me that she's worked on real software and done big software projects, because this is what real code looks like.
Okay, so this is what it would look like. And then I only need to do is find first and find last.
Okay. Now, I've asked this question quite a few times in interviews. I can see that there's actually a bug in there. Let's see if Laura can find it. So do you want to give me a dry run of that and see how it works?
So yeah, I was going to, so suppose the indices here are 0, 1, 2, 3, 4, 5, 6, 7, 8.
Yeah.
And well, we'll stick with the example of 3. If I find first, the first index is going to be 3 in this case, and the last is going to be 6. So I suppose I implement this correctly. And so I'm going to return the 6 minus 3. Right, 6 minus 3 is 3. This is wrong, actually, because we have 4 3s in this case. So I'm thinking, I think we need a +1 here.
Yep.
Right, actually, because if I was looking for a 5, for example, the first index and the last index are going to be the same, and the answer is still 1.
Yeah.
So
So this is great. I mean, Laura made a mistake. It wasn't a big one, and with hinting, she has figured out the right solution. And that's really impressive that she's done that, and you know, she's someone that I could work with, which is brilliant.
And actually, now that I thought of this case of the 1, there's the case of the 0 here as well. So
Well, you don't
it
find
could be
anything.
if I get a 10 here that isn't in the array, my find first or find last are going to fail in some way.
Okay.
I'm thinking, well, there's plenty of find functions in Java that are about finding an index that would return -1 if the index isn't found. So
Right,
I could stick to that convention and assume that find first and find last are going to return -1 if they
Okay.
don't find any index. So in that case, do you mind if I? So
No,
I think
add
it would
that
be
in, that's
here.
great.
It will be in here. I'd say if
So Laura's showing me sort of advanced knowledge. She knows about default return functions, find values, which is
x equals
really good.
to -1, I simply return 0 because I know that my count is 0.
And why have you
Right.
done it in between here?
Well, there's no point in trying to find the last index. If I couldn't find the first, it means,
Absolutely.
I mean, there's no big harm, but no point in looking, right?
Yeah. Okay. That's great. So now then, we should think about writing them.
Right. So the next thing would be to write these two functions. Should I go ahead? These two would be quite similar, I suppose. It's going to be some version of a binary search
Yeah.
that is checking for first and for last occurrence.
So if this was production code, would you write 2 functions there?
I suppose this production code would look more or less like it does, and
Yeah.
then for find first and find last, and I might use some helper functions that are abstract out the common part of the binary search.
Yeah.
To be honest, I'm not really sure what that is at this stage.
Okay.
So I suppose I would just start by writing one of them and then seeing which part of this can be extracted out to common code. But yeah, I understand that it would be duplication, and it would be a good opportunity to find the spots and fix them.
Okay, that's fantastic. So yeah, let's for now, we're pushed for time, so let's just write find first.
Okay. So I'm going to let's flip over here. All right, we have the same example. And so this is still going to return an integer because it's the index.
Yep.
And I'm going to call this find first. I'll pass in the same array and the target.
Yep.
And this is going to be a binary search, right? So I'm going to do the classic iterative binary search where I start with the 2 indices here at the ends of the array.
Yep.
And I'm checking the middle point to see if this is the one that I'm looking for. And if it isn't, I'm either going to adjust the last one or adjust the first one and look again to the half of the array where I need to keep looking.
Okay, so if you hadn't done it iteratively, is there another way that you could do that?
There is the recursive version of this same thing, which is just introducing an auxiliary function that receives, on top of these two, receives the beginning and the end, and just passes different beginning and end. But in principle, it's very similar.
Okay, so any downside to doing recursive functions versus iterative?
Well, like one could argue that there's a stack trace problem with the recursive solutions, although there are clever ways of writing recursive functions that don't cause these problems. And I think for something of this size, I would not worry about like running out of a stack to make recursive function calls. So no, I think in this case it's just personal preference.
Fine.
If that's okay.
Yeah, no, stick with iterative. It's
Cool.
great. So that was really good. So Laura has shown me that she knows about recursive functions and she knows what the drawbacks are without actually having to write a recursive function. So all the time that we're talking, I'm learning more things about Laura's knowledge and her experience, which is really very valuable.
So I'm starting with F for first and L for last, and these
Yep.
are the 2 indices, and I'm going to go on looking until basically until the indices cross, and that means I've exhausted the whole array and I haven't seen my target.
Yep.
So I'm just going to go while F is less or equal to L,
Okay.
and I'm going to find the midpoint. F plus L divided by 2.
So what happens if this is an odd number, if you end up with mid being 2.5, for example?
Well, this is integer division, so it's going to just pick it's not going to come up with a 4.5, it's going to give me the 4.
Yes, exactly.
Which is fine. It's basically what I'm after. I'm after an index here. So this is good. So at this point I have the mid number and I want to check if it's the target, but not only if it's the target, I'm looking for the first occurrence of the target.
Yeah.
So if that's okay, I'm just going to delegate that also to, I'm going to punt it to another function.
Okay.
And say if first.
So this is a good technique because not only is the code very readable, but it's given Laura a bit more time to think about what is first is going to do internally.
So if it is the first one, all I
Yeah.
have to do is just return this mid index.
Right.
And now if it isn't, well, I'm either at 2 stages. I am either seeing a number that is smaller than my target, so smaller than my 3,
Yeah.
or I am seeing a number that is either bigger than my 3 or it's 3 but isn't the first.
Okay.
So I'm going to start with this one just because it's easier to express. If I'm seeing a smaller number, it means that I need to look to the right. So I'd say else if here I'm seeing the number I'm seeing is less than my target,
Yeah.
then I want to keep looking toward right. So my first is going to be updated to my middle point plus 1.
Right.
And then I go back to my while loop.
And the
So-
middle point plus 1 because you've already checked the middle point,
Right.
I guess. Right. Okay. That was a really
And
nice
it's
explanation from
not.
Laura there. Sometimes it gets very confusing doing a binary search and things being less than or greater than. But Laura explained her thinking really clearly and she's written it down and got it right, which is fantastic.
Okay, so, and on the other case, all I need to do is to update my last to mid minus 1. And if I'm done with the while loop and I'm out of it and I haven't returned anything, it means that I've exhausted all the array and I haven't seen my my target. So in that case, I said I was going to return -1
Yeah.
for the case of not found. So this is return -1. There we go.
Excellent. Okay.
So now all there's left to do is implement this thing that I owe you.
Okay.
I'm going to just use this bit of whiteboard here.
Yeah. See, normally you'd have much more space. Today we've got quite a small area for drawing on, so we're squeezing stuff in the corner here.
So it's a Boolean. I'm just going to say yes or no. Is this the first one?
Yeah.
And I have my numbers. I have an index. And I have my target. And so this is going to, well, there's a opening bracket here. So this is the first one if it is one occurrence of target. So this is basically going to return whether an S at I is T.
Yeah.
And also I want the one before I to not be T.
Yes, that makes sense.
So an S at I -1.
That is first function. It's
Isn't
actually
T.
quite simple. I thought that it might be more complicated, but it's nice and simple.
Okay.
However, there may be a problem with it.
All right. So yeah, I'm happy with this.
Okay, that looks good. So how about?
So we're on to an example.
Perfect. Yes.
Okay. So maybe we could use this example. I think it's small enough to, or binary search hopefully will come to the rescue and make it fast. So I'm going to pass. This is our NS and this is our T, our target.
Yep.
And I'm starting here by defining F and L, and well, I'll use this space here to.
Yeah.
F starts being 0 and L starts being 8.
Yeah.
And I go into the while loop and mid starts being 8 divided by 2.
Yes.
That is 4.
Great.
And so the next thing I'm going to do is whether 4 is first. Well, 4 is pointing at this 3 here, which is a 3, but it isn't the first 3.
Yep.
So it isn't the first. I'm going to the next if statement that is looking at whether this 3 is less than 3, also not true. So I'm going here, and it's that the last needs to be updated to mid -1.
Yes.
So last stops being 8 and starts being 3.
Okay.
And I go back into the while loop. M is now 3 plus 0 divided by 2. That is 1 in integer division.
I really like the way that Laura's doing this. It's great. Seeing all the variables being crossed out and the values changed makes it very clear.
So now we're looking at this one. This one is not an occurrence, so this one is going to return false. I am in this case now. So now I have to update my first to mid +1. First stops being 0 and starts being 2. And I go again into the while loop. My new midpoint is 2 plus 3 divided by 2. And that is 2 plus 3 is 5 divided by 2. That's 2. So I'm looking now at this 2 here.
Yeah.
And I am again in the same case. So I'm going to update the first from 2. And now it starts being mid +1, which is 3. I go into the for loop again because I'm checking for greater or equal,
Yeah.
which is good. This is the one that I'm looking for, actually. So its first here is going to return true, and I'm just going to return 3.
Okay.
So this is the...
You didn't update your M here.
Right.
But yeah, that's fine.
M starts... Yeah.
That was a really good dry run of the code. But you may have noticed that she didn't actually test all the code out. There's the isFirst function, which Laura kind of assumed was working. Now, I think there's a problem there, and I'm going to help her find out what it is. So that's a good dry run. How about if we try some different test data on it? So, Natalie, what would it be like if I gave you 4 3s in a row?
So, same thing. We start with first being 0. Or if I can just write the indices in here, these are 0, 1, 2, 3. It's just more convenient.
Yep.
So F starts being 0, L starts being 3, and my first midpoint is going to be 3 divided by 2, which is 1. I'm looking at this one.
Yep.
It's not the first occurrence, so I am, in this case here, I'm going to update my last to 2. and I go into the for loop again. The midpoint is now 2 divided by
Which,
1. No, what did I do wrong? Is it still 1?
Let's have a look. No.
No, it can't be still 1. Hang on, I am seeing this. I'm
Okay.
here.
So it's fine.
My
I mean,
last
Laura has
It's the
made a mistake.
minus 1. Oh,
Doesn't
okay.
matter.
This one is 0. There we go.
Okay.
That makes more sense. So my new midpoint is now 0, which is the one that I'm after.
Yep.
Because well, I see that 0 is the first occurrence of the 3, so this is going to return 0, and 0 is the last one that I return.
Okay. Laura's kind of fallen into a trap, I guess. Tell me about is first and what happens when you call is first with 0.
Oh, okay. So I'm passing 4 3s. My I is 0 and t is 3, and an s at I is 3.
Yep.
And an s at I minus. Oh, okay. An s at I minus 1 is undefined in this case. Right. This is missing a case. When I'm looking at the first element of the array, that is always the first. If it is an occurrence, it is the first occurrence because there's nothing beforehand.
Yeah.
So I suppose.
So the problem is here, if you're indexing the array at
Yeah. So
minus 1.
the fix for this is to say either I is 0. So
Okay, so Laura has found the problem and she's fixed it. The fact that she created the bug in the first place isn't a problem. We all write bugs when we write code. The fact that she's found it and fixed it is fantastic. It would have been even better had she proposed her own test data that would have found the problem to start with. But I'm not too worried about that. The fact that she's found it and fixed it is just fantastic.
So it's either I equals 0 or
Yes.
or then.
Okay, I think that's really good. That's a good solution. Right, so I think that probably wraps up this. So I hope you've enjoyed it, your time here. Do you have any questions for me about Google?
Well, normally I would have plenty of questions for you, for your what your job's like, what you do here at Google, and questions about life at Google in general. For the sake of this video, what I'm going to do is I'm going to let the audience ask our questions. I'm going to kick us off with the first one, which is, Simon, this question here that we did, it actually looks pretty simple. Is this really the level of questions that we get at technical interviews at Google?
Yes, I think it is. It looks simple, but I've learned so much about you. We talked about recursion, about scalability, loads and loads of things came out of it. So even though the code might look pretty simple, I've learned an awful lot. So yes, absolutely. This is the kind of question you can expect. We're not going to be asking you weird, bizarre questions. They're going to be, sensible things. And it's how you answer them that really is the main thing. And you've done a really good job here today.
So the one thing that I can add to that is if there is time on the interview to move on, this is going to be probably an introductory question that is going to get more complicated along the way. So there could be a new question introduced, or this could have follow-up questions about how can we test it, or what's happened when the array doesn't fit in memory actually, how would we go about looking at that. So it's always, it starts with things that look simple, but maybe aren't necessarily, and then it grows more and more complicated, and we'll basically go as deep as we can with the interview for the 45 minutes that we have time.
Absolutely.
So we have a question now from Elena. The question is, can too many questions to the interviewer be annoying? Do you want to take this one?
I've never yet been annoyed by too many questions. I think if it's obvious that the candidate is stalling for time, asking questions because they simply have no idea, that's not good. If you don't have any clues, then ask for some hints and clues from the interviewer. But no, ask as many clarifying questions as you can to make sure you're answering the right problem.
Or pretend you're working with a colleague and you're basically trying to get the problem statement correct. So you're working with them to make sure that you're doing what you're supposed to do.
Yeah. Okay, another question from Najwa. Sorry if I pronounced that wrong. Is it okay to take a moment in the interview to think rather than thinking out loud? So Laura, what do you say?
Absolutely. We do want to hear your thought process as much as we can. You have your 45 minutes there to shine and to let us know all of your skill. So we do want to hear what your thought process is. If you want to say, let me think this through for a minute and just take 30 seconds, 1 minute to think and not say anything, or maybe do some drawings on the whiteboard and so on. Just let your interviewer know that you're doing this. At some point, your interviewer may actually prompt you for a bit more of, tell me what you're thinking or what are you drawing there. And it's your time as well to explain what your thought process has been.
Yes, I would agree with that. Don't just go silent. Say, I need to think about this for a moment, so that your interviewer knows that you're actually thinking.
Right. Okay, next question from Shir Karen. He says, I've faced some interviewers that stay silent as say nothing. Are there any tips on how to handle this kind of situation?
Goodness me. Well, I hope if you have an interview at Google, that will never happen. We have a lot of interview training, so we know how to conduct good interviews, and we would never go silent. I would prompt the interviewer to say, am I on the right lines? Have you got any hints for me? Is this the right solution? And just ask more questions, basically, but it should never happen at Google.
Yeah, so one key question that you can use a lot is, shall I go ahead and implement this solution? So after you've explained your ideas, this is a very clear yes/no question. So shall I go ahead and do this, or did you want me to go to a different path? So these are all very clear questions for an interviewer that will spark an answer.
Yeah.
Yeah. Okay. Your next question.
Okay, Srija. I would like to know if we are expected to start with the brute force solution and develop the most optimal solution from it. That's a good question.
Yes, and there is no one single answer to this one, I'm afraid. The answer, I would say, is it depends, and depends a lot on the question. It depends a lot on your interviewer. I think all questions start with a conversation, whatever that is. And sometimes the brute solution is complex enough or has enough interesting code in it that the interviewer is going to want to see it. And you're right by explaining what you think the most obvious solution is, offering to implement it, and the interviewer will tell you if that's not worth it, really, and say, no, let's think of something more clever than that. Or the interviewer is going to say, yes, go ahead, implement this, and then we'll look on how we can improve on it.
Yes, I would agree with that. I think if you propose the brute force solution as if it's the only thing you can possibly think about, then the interviewer won't be that impressed. If you say, this is a brute force solution, are you looking for more than that? Then that's a good conversation opener. And the interviewer will be aware that you know that it's a trivial solution if it is one. But as Laura says, sometimes the brute force solution is the correct solution.
Okay, one more. How much time on average would the interviewer expect for you to spend on solving a problem?
Well, so that can change. Depends on the complexity of the problem. So the problem we've had here today took about half an hour, and that's reasonable. Sometimes you might start with very simple problems that maybe take 5-10 minutes. Worst case, I think I've asked maybe 3 problems in an interview. I've never had to ask more than 3. So for a 45-minute interview, that's about 15 minutes per question. But the interviewer will be in charge of the time. So if you're taking too long, the interviewer will say, okay, we need to move along now. So you don't need to worry about that.
Yes, so to that question, I always give the same advice. Or when I coach interviewers, they are responsible for keeping time. An interview that goes wrong can be one in where a candidate gets stuck and makes absolutely no progress in the whole half an hour, but still it's not the timekeeping itself is not the responsibility. The thing that went wrong is that despite the hints, no progress was made.
Yeah. Okay,
More
on from
questions?
Eleanor. Do you want to read this one out?
Okay. Is it okay to have some mistakes in function names or syntax in the interview code, or it will be 0 points because it won't compile?
No, it doesn't matter. I think no one is ever going to compile the code. We're not checking your ability at typing or your knowledge of syntax necessarily. We care about your thought processes and that you understand the algorithms and the data structures. So yeah, make typos plenty.
This code probably doesn't compile, does it? The code that I just written. Well, who knows? But no, it's code on the whiteboard. It's fine if it doesn't compile, and also it's fine if you don't remember the name of a particular function. The array, in this case, there was the array.length. I could have forgotten how you get the size of an array or mistaken that for size and written array.size, and that's usually not a problem. If you forget a function and want to ask its name, it's also okay to ask your interviewer.
Yeah, absolutely. Okay, we have another question from Peter. In a phone interview of 45 minutes, can I expect to be interviewed on topics like dynamic programming, which are quite tricky and time-consuming?
I'm just going to go with my default answer of it depends. It's true, I agree that they are tricky and they are time-consuming, and it can happen that you start off by writing a code that is simpler than this. When I think of dynamic programming solutions, lots of the time I start by writing it the recursive way through them to understand them, and then maybe your interviewer wants to see that code, and then wants to see you discuss how you would evolve that into a dynamic programming solution without actually writing out the full fleshed out solution because of time. But again, you are, depending on the question, and because interview questions vary and interviewers vary, it would score you points to know dynamic programming and to know how it would go about. And you are right in that most likely you won't have the full interview to write a full entire dynamic programming solution. I don't know if you've ever seen
No, I think that the phone interview is more about width, sort of breadth of knowledge rather than depth of knowledge. So you'll be asked on lots of different things. You'll be asked about data structures and algorithms and bits and pieces like that. You wouldn't spend your entire, well, normally you wouldn't spend your entire phone interview on a single question. There's a lot of interaction that takes place during a more complicated question. So this one here, I learned most of what I learned about Laura not from the code that she wrote, but from our interaction. And sometimes that can be missing on a phone interview. So you're just checking breadth of knowledge at that point.
All right, so a question from Eniselda. I am very interested to know what are the main characteristics that make a difference in the evaluation of a candidate. How important are the traditional elements such as GPA? Simon, what's GPA?
I have no idea. What's GPA? Does anyone?
I am going to go ahead and assume this is about the scores that you got in first years of university or in the last years of secondary school leading to university.
I think that's right. I'm getting a thumbs up from asking that. Well, actually, given that I didn't know what GPA is, I think is the answer. That actually traditional elements such as GPA are not important at all.
Definitely not during the interview. When evaluating a candidate's application, the committee that is looking at it, it's going to look at the full CV. And so maybe marks are important in that context, but not during the interview for sure.
In particular, something that is unusual at Google is oftentimes we don't even we don't talk about the CV or the experience of the candidate. What we care about initially is that they have that technical skill. And then once they've passed the interviews, at that point the CVs become useful because we can then decide what would be a good area for them to go into at Google. But really, on the day is what matters most. It's the actual interview itself. Right, a question from Eleanor. Graduate interviews, do they require skills in software design, or is it more concentrated on algorithms and only algorithms?
So your set of technical interviews is going to vary. You're probably going to have some questions that involve some level of object-oriented design. So we want you to be able to design a class and to choose which methods the class are going to have and which underlying implementation the class is going to have or design a couple of classes and how they're going to interact together. So we do expect that in technical interviews for that level of interview of candidates. We don't expect the design of a full scalable distributed system that is handling millions of requests per second. That's not the kind of questions that you're going to get. But we do want you to design something that is the API or the interface of the class and how it's going to be implemented.
Yeah. So if you end up on site having 4 or 5 interviews, probably 4 out of the 5 interviews will just be algorithmic and sort of software skills, and possibly one of those will be system design. So it's important that you understand the ideas in that, but you won't be tested. It's not the majority of the interview by any means.
Yes, and it's not for new graduates, for sure.
Okay.
If you're just fresh out of university, you don't get one of those interviews. This is for people who have a bit more experience, and I have worked in software for a few years.
Yeah. Okay.
Okay, next one. How likely is it to get questions like the one in Code Jam Kickstart, the competition on Sunday, in an actual Google interview? I struggled terribly at it. I remember what the questions were. Those questions are a bit too elaborate, I would think, for an interview, because they take time even to read through and understand. This was I can say for everyone. I'm going to say what I remember to the best of my ability. There was a question about a deck of cards and a kind of a solitaire game on the deck of cards where you would pick consecutive cards that matched a certain criteria. The cards had numbers in them, and the numbers had to meet a certain property. And it was about finding out how many of those runs could you do until you, the maximum number of rounds that you could do meeting this criteria until you ran out of moves, and how many cards left on deck, and things like that. The question itself was kind of hard to, it needed a lot of actually reading to find out what we wanted. I've never seen a question that long explained inside of an interview. And I would, if on one end we put those questions, and on the other end we put the ones that we did today as an example, I think the interview questions are more similar to this one, but they do get more complicated with time as you have time to get used to that and think through the problem.
And bear in mind that you're not alone in the interview. You have the interviewer with you who wants you to succeed and will be helping you and giving you hints. So if you're struggling, just say, I have no idea, can you give me a hint please? And you'll get a hint. So you won't be struggling on your own. Question from Yumna. After how many hints do you consider too much before deciding to change the problem? That's a good question.
My answer is it depends. It depends on the problem. I definitely don't count the hints. If I find that I've proposed a problem where the candidate is really, really stuck and we're just making no progress, I do want to make the most of my time during the interview, so I'm just going to change the problem to give the candidate the chance to shine and to show their skills in some other problem. Because it could be that it's simply like miscommunication, something didn't work out in this one particular problem, well, let's move on to something else. The decision of let's move on to something else because this didn't work out could be, I don't know, for how long I would, if we are making absolutely no progress, I don't know, say past 10 minutes of discussing or 10, 15 minutes, to me that would be a pretty good sign that it's time to move on. And again, it could be simply a communication issue. Yeah,
I would agree with all of that and say, again, the interviewer wants you to succeed, and the hints will get less and less hints until they will tell you what they want sometimes. I will certainly say, so today when Laura was refusing to change the binary search thing and going for a linear solution all the time, at some point I would have said to her, why don't you do a binary search to find the first one and find the last one? So that hint would have actually been giving the solution, and I've done that a couple of times in interviews. And it isn't necessarily a bad thing. It gets you over a hurdle, and you can then shine later on in the interview.
Right. Okay, so that wraps it for today. Thank you all for tuning in and for asking questions. We have not managed to get through them all, but there will be more opportunities in the interview workshops that are coming up in the next few weeks.
Yeah, so in the meantime, take a look at the problems in the newsletter and upload your solutions. If you get stuck, ask questions on the G+ community. Lots of people there will be able to help you. So that's all from Laura and me. We'll see you again on the 19th of June. Until then, bye-bye, and thank you for being here.